Hello, boys and girls. As we've been going over last week and this week, we've been discussing equivalent fractions. Now, we will finish up this week with equivalent fractions, and today's lesson will be continuing, extending our learning of equivalent fractions. So if you have any questions, you can ask me during our live classes, or your parents can email or class dojo me. So here's our lesson for today. Our lesson today begins with the definition of equivalent fractions. Equivalent fractions are fractions with different numerators and different denominators that represent the same part of a whole. Again, equivalent fractions are fractions with different numerators and denominators that represent the same part of a whole. Let's take these two squares for example. Each square represents one whole. The square to our left is broken up into 4 parts. Therefore, we know the denominator is 4. We've shaded in 2 of those parts. Therefore, our numerator is 2. That means our fraction representing that square is 2/4. The square on the right is only broken up into 2 parts. Therefore, our denominator is 2. Only one of those parts is shaded in, so our numerator is 1. That square is represented by the fraction 1/2. These fractions are equal. They're equivalent fractions because 2/4 is the same shaded part as 1/2. Let's use the same example to picture it on a number line. Both of our number lines start at 0 and end at 1. They both represent one whole. The number line on top is only broken into 2 parts. Therefore, the number line on top only is separated into halves. The number line on the bottom is broken into 4 parts. Therefore, each part is 1/4. On the number line that are broken into halves, if we move from 0 to 1/2, it is equal to if we moved from 0 to 2/4 on the fourths number line. These fractions are equivalent fractions. Let's take another example. These shapes are the same size and both represent one whole. But the shapes aren't broken in the same amount of parts. The shape on the left has only one shaded part of 3. The shape on the right has 2 shaded parts of 6. The shape on the right has a denominator of 6 because there are 6 parts. The shape on the left has a denominator of 3 because there are 3 parts in that whole. The numerator of the shape on the left is 1 because only one part is shaded in. The numerator on the right is 2 because 2 parts are shaded in that shape. However, these fractions are equivalent because they shade the same part of the shape in. Again, let's look at it from a number line. Both number lines stretch from 0 to 1 whole. The number line on top is broken into 3 parts. Therefore, our unit fraction is thirds. The number line on the bottom is broken into 6 parts. Therefore, our unit fraction is sixths. On the number line on top, the thirds number line, if we move from 0 to 1/3, it's the same as moving from 0 to 2/6 on the 6th number line. And that shows it right here. These fractions, 1/3 and 2/6, are equivalent fractions because they have different numerators and different denominators, but they represent the same part of a whole. Now let's go over the quick method for finding equivalent fractions. This is used either through multiplication or division. Let's start with multiplication. We want to find a fraction that is equivalent to 2/4, and this fraction has a denominator of 20. So, we multiply 4 times 5 to get a denominator of 20. If you multiply the denominators by 5, that means you have to multiply the numerators by 5. 2 times 5 is 10, therefore our numerator is 10. 2/4 is equivalent to 10/20. Let's try to find an equivalent fraction to 3/8. This time, we know that our numerator is 9, so we have to multiply 3 times 3 to find 9. On the bottom, our denominator, we also have to multiply by 3. Therefore, we have a new denominator of 24. 3/8 is equivalent to 9/24. Let's try one more. We don't know what our numerator is with the denominator of 25, but we're trying to find an equivalent fraction to 3/5. If we multiply the denominator by 5, 5 times 5 equals 25. Therefore, we need to multiply the numerator by 5. 3 times 5 is 15. 3/5 is equivalent to the fraction 15/25. Now let's use the strategy with division. We want to find an equivalent fraction that is equivalent to 10/15. 15 divided by 5 equals 3. Therefore, we know a denominator could be 3. 10 divided by 5 is 2. Therefore, 10/15 is equivalent to 2/3. Here's another example using division. 6/24, and we're trying to find an equivalent fraction. Well, let's divide our denominator by 2. That'll give us a new denominator of 12. If we divide it by 2 with the denominators, we also have to divide by 2 on the numerators. 6 divided by 2 equals 3. Therefore, 6/24 is equivalent to 3/12. Now, let's change our direction to see how equivalent fractions work in money. Let's use quarters and dimes. We know that 4 quarters equals 1 whole dollar. We know that 10 dimes equals 1 whole dollar. 4 quarters equals 1 whole dollar, and 10 dimes equals 1 whole dollar. So, if I had 4 quarters and you had 10 dimes, we have the same amount of money. We can use fractions to display the money. 4/4 equals 1 whole. Therefore, 4 quarters is $1. 10/10 is 1 whole. Therefore, 10 dimes is $1. But let's say I had 50 cents and you had 50 cents. But I had quarters and you had dimes. That means I have 2 quarters, or 2/4 of a dollar. And that means I have 50 cents. You, however, would have 5 dimes, or 5/10 of a dollar, which is also equal to 50 cents. That means 2/4 of a dollar and 5/10 of a dollar are equivalent fractions. It means you have the same amount of money, as I do. I have 50 cents, but I have 2 quarters. You have 50 cents, but you have 5 dimes. 2/4 of a dollar is the same or equivalent as 5/10 of a dollar. There's an example of how equivalent fractions exist in money.